Okay, this is problem B3. It's a calculator problem. It starts off fairly simply. You're given information about a tank, the area of the tank at a given height, and you can tell that as the height increases, the area of the tank is decreasing. And they tell you as much right here. The function a is continuous and it's decreasing as h increases. Okay, so your first problem is to use a left Riemann sum with 3 subintervals to approximate the volume of the tank. Okay, so I've drawn a picture of this, and here we have our information again. This isn't what it looks like, but if this is the tank, notice that I tried to make it look like the cross-sectional area is decreasing as the height of the tank goes up. And the volume of the tank, well, if we want to find it exactly, if we had the equation for the area of the tank, we would just add up all of these little volumes of these slabs, and the volume of the slab would be the area of that slab times the height, in which case, if we're finding the exact one, would be a change in h. But what we're doing is we're using a left Riemann sum to approximate this. So I plotted the points right here. There's my 50.3, my 14.4, and so forth. And so I had to break it up into 3 subintervals, and I only have 3 intervals. But then it says use a left Riemann sum. So I'm using the leftmost point, and I'm just finding the area of that rectangle, this one, and this one. Once again, the area of each rectangle would be this area times that height, and that gives me the volume. So there's the work for that, and I get my answer. Okay, but then on part 2, just a conceptual question, is this approximation an over or underestimate? Okay, well, if we go with what they said, that it's a continuous, that the area is a continuous and decreasing function, and it's going through those 4 points, okay, the left Riemann sum is using the highest value of each subinterval. And so the area of the rectangles is clearly bigger than the actual area under that curve, and so this would be an overestimate since it's a decreasing function. Okay, and then part C. Okay, now they actually give you the equation of the area at a given height. So f of h is the area when the height is h. Okay, and now they're saying find the actual volume of the tank, and that's what we talked about earlier. Okay, the volume is just going to be the sum of all of these slabs here. Okay, so here's my area function. The volume at a given height would be the area under that curve from 0 to that height. Now we wanted the entire thing. The tank is 10 feet tall, so we're going from 0 to 10. Okay, and so here I have it. And if you get to a point like this on the AP exam and you realize you have no idea how to evaluate this, don't forget you get a calculator. Okay, so just use your calculator to evaluate that integral, and there we go. Okay, so D is I think a very challenging question. It's the kind where I want you to realize you've done parts A, B, and C, and you've gotten probably about 3/4 of the points on this problem. Quite simply, that's a 5 on the AP exam, so don't stress out about something as difficult as part D. So let's go ahead and look at it. Okay, so we're pumping water into the tank. Okay, when the height, realize this is a height, not a time. When the height is 5 feet, okay, the height is increasing, so this is a dH dt at 0.26 feet per minute. Okay, and what they're asking us to find is the rate at which the volume is changing. So that's a dV dt. Okay, when the height, not the time again, is 5. Okay, so here I have it. dH dt is given to us when h is 5. Okay, and so this volume formula we worked with, this is a function of h. Okay, notice that we have the h in here. Okay, since it's a function of h, if I derive it not with respect to h, but with respect to t, there's a chain. So dv dt is right here. Clearly, you can see that it's equivalent. Now, you can't really cross those off. But the chain would be the dh dt. And note, that's what we're given. Okay, and then the derivative of the volume with respect to h is the derivative of this function for some whatever height you're considering right there. Okay, and so here I have the volume for a given height is from 0 to whatever height you want. So I just used a variable there of that a of h. Okay, and maybe I should have used f of h right there like they used. Okay, so anyway, I'm deriving this with respect to t. And I realized up here that dv dt is dv dh. And so that's what I have here, dv dh, the volume derived with respect to h, okay, times that chain dh dt that we're given. Now, I hope you recognize this as the fundamental theorem of calculus. Okay, the derivative with respect to h from 0 to this variable of that is just a of x. Remember, we said that we're only interested in when the height is 5. And so honestly, I really should have used f right here. So I just replaced the x's with 5, or the h's with 5, I should say. Okay, I used my calculator to evaluate it and multiply by the 0.26. And don't forget to include the units. You probably should express this as a sentence on the actual AP exam. Say when the height is 5, the volume is changing at a rate of 1.694 cubic feet per minute. Okay, so tomorrow's problem is a no calculator problem, and there it is. Good luck.